Hi, Kiernan.
Hi, Kiernan.
Hi, Kieran.
I don't know why I do that.
Hi,
Jay
Kiernan.
Stoner.
Why isn't she
She's like doing water polo
Colombia.
stuff in Brazil or something.
She's in like Colombia, right?
Yeah.
That's so
Yeah,
cool.
like
like-
doing water polo. Okay,
Are you checking for your melon?
Yeah.
we're gonna go over each of these sheets. So do you
You're gonna
have
test your
unit
melanin?
5 out right now? These are the two that I gave you on, whatever it was, Thursday.
I did mine on computer, but
Okay.
I didn't try on my
Who's
iPad.
doing the most?
Do you not have it with you?
Well, I have my iPad. Can I just
Yeah, take it right now. I just wanna, it doesn't matter to me, I just need you to have the information.
Mr. Labonte, does sunscreen like fully work like blocking cancer?
Repeat?
Is sunscreen like fully block cancer?
Oh, who did the sunscreen one?
Me?
Yes, sorry. Say what, you answer that question. I thought you did a great job
Thank you.
of differentiating between the two types of sunscreen.
Okay, what's your question?
Asking, it's very, very.
Does it block cancer? Like fully? Like if you apply it like
Like if I'm in
the recommended
sunscreen
amount?
on, am I gonna die if I'm in the sun for the rest of my life? But I have
Okay, okay.
sunscreen.
No.
It's gonna
Be-
break your skin.
better question. If you apply it like the recommended amount, is it gonna block the sun like the whole time?
Fully, like I'm not gonna get
Yeah,
skin
if you
cancer, even if
keep-
I'm in the sun every
I
day.
mean, it's gonna come off a little bit from like external, or depending on which one you use, if you have chemical or
Okay,
mineral.
I'm doing too much. Just
Well, no, you're asking specific questions.
I'm not asking the overall question.
No. Because to answer it, she needs to be specific about it. You did a great job. Say exactly what you said in your
Make him do
presentation.
push-ups.
There's two
There's
different
two
kinds.
different kinds of sunscreens, mineral and chemical, and most likely you want to use mineral because that will, if you keep putting that on continuously, that will block your skin from being burned. Well, they both will block your skin, but then if you use chemical, then some of that sunscreen will go directly into your bloodstream and then impact your body
You don't want that for
Do I want that or not?
But also
No.
the chemical one, which you said in the review, the molecule gets changed by the sun, whereas the mineral one never does.
Oh yeah,
So
it
the mineral
changes
one will
structure.
always be the same. Yeah, that's right, you did a great job.
Thank you.
All right, so we are here, Unit 5 review sheet. We are not going to do this whole thing, because otherwise we won't get through everything. But we're gonna do we'll do, what I
I'm gonna
do.
keep it a buck.
Kind of,
You gonna keep it above?
So, are we ready to go?
All right.
Mr.
Rand.
Labonte, do you have a stapler?
Yeah, they're both all.
You didn't text me to send it to you.
What an idiot.
Hi, Kiernan. Hi.
All right,
Yeah.
let's do this quickly. Make that table and try to fill it up. Proton, neutron, and electron, right?
Wait, I don't want to do that at all.
It's still too bright.
Wait, go like this.
Go, Hazel.
Yeah, I got it. Right, I got you. Yeah.
Say hi.
Did that work?
Yeah.
Okay, great.
You got a pencil or a pen?
All right, proton, neutron, electron. Does everybody see the chart you're trying to fill out?
Do you want a pencil?
Sure, that was.
How to do all this?
Yeah, I got a pencil for you.
Thanks, Brandon.
Filling out the chart.
I don't know the chart.
Charge, mass. Just, this might be hard, but maybe not. This shouldn't be that hard. What is the charge of a proton, the charge of a neutron, the charge of an electron?
Okay.
Yeah?
Trojan Max. It doesn't have a
All right, are we ready? This was just 6 boxes. Here we go, yes? Proton has a
+1.
charge. Neutron has a
0.
0. Electron,
-1.
-1, right? And you take +1 there. Yes, good so far?
Yes.
All right, so that's our charges, yes? Now, how about mass? Does proton have a mass?
1.
Yeah, 1 AMU.
Oh.
Neutron,
1.
1 AMU. Electron,
0.0000000.
just for our purposes, we'll just call it 0, right?
And you.
It's technically
Yeah.
not 0.
It is technically not 0, but we'll just say roughly 0 AM. Okay, good? Definitely have to understand that, like, know that, yes?
Sure.
Right? So then, that helps us understand the identity of something. So what is a mass number? That consists of what? Protons plus neutrons, right? Protons plus neutrons. That's our mass number. So using that, we should be able to figure out all of these values, yes?
Yeah.
Does that make sense? You're just gonna add protons and neutrons up, and these are all, we're gonna assume that they're in a neutral state. So electrons will always be equal to, atomic number is 100% right. Electrons will always be equal to atomic number Y. What is atomic number equal to? Protons. So atomic number, protons are equal. If it's at 0 charge, electrons are always equal to the number of protons. Good?
Do we get a periodic table for the
Yes.
test?
Yes, you'll get a periodic table for the test. You'll also get a table of electronegativity, this, so you'll have all of this, okay?
Turn out my pictures.
So, we're gonna move from this, I'm not gonna do this chart with you, I'm assuming you'd be able to do this chart, or you have done this chart since I asked you to look at this for review, yes? And we'll go down. Make sure that
That's good.
you know the families in the periodic table. Okay? So make sure you know those. But now let's get to radioactive decay. First of all, fusion and fission. I don't know what the easiest way to remember this is. For me,
Is fusion
yes, great. That,
2 going to
for
1?
me, that's the way that's the most helpful to remember. When you fuse something, you take two things and put it together, right? And then fission is the opposite, right? So fuse, put things together, okay? So that's nuclear fusion, nuclear fission. Where does nuclear fusion occur?
The
On the
sun.
moon or in stars?
sun.
Sun.
The stars are
Sun
stars.
and
The
stars.
moonians.
And then this is
Stars.
U-235, usually, like uranium-235, nuclear power plants, atomic, nuclear bombs, right? It depends on.
And
what
that happens
you
on
mean by
stars?
bombs. Sorry?
Fission happens on stars.
Fusion
sun
happens
stars.
in stars. That's why there's an arrow, right? Fusion is in stars. Fission is in nuclear power plants. Yeah.
What atoms split during like fission? Like is it any atom or is it like I mean in
No,
the atom
well,
bomb?
it could, there are different atoms like protactinium, tinium, but uranium-235 is generally what's used, enriched uranium. So, Hayes, did you have a question on this? Okay, we good, we're moving on? Grant, then, what are the 3 types of radioactive decay, and how do they work?
Alpha, beta,
Alpha,
and
beta,
like theta or
gamma.
something.
Good, so we have alpha, beta, gamma.
That one.
Okay, so let's go, do you guys want a periodic table? Did you do this already?
Yeah.
Yeah.
You guys all did this? Grant,
Uh,
okay. So bismuth undergoes alpha decay. So alpha
Is gamma just?
is 4 to He,
Yeah, right?
right?
It's a Y, it's like the Y.
That's what an alpha particle is, right?
Yeah.
Yeah.
So when you undergo decay, basically you can think of it this way, your proton number is gonna go 2 to the left or 2 down. Yes, that's gonna be a new element. Good? Everybody's okay with that?
Yep.
Brad? And yes, gamma is just energy, that's my attempt to draw gamma for the Greek letter. Is just energy. So there's no change in charge, there's no change in mass.
So it doesn't
Okay?
change?
Now, finally, beta decay, okay? beta decay is an electron, and what will be helpful to remember.
It's, I thought it was 0 over there.
I thought it was zero.
Zero,
Oh, I'm
negative
sorry.
one.
Mass. Sorry about that. Okay, what's helpful to remember is a neutron is really a proton plus an electron. So when you have beta decay, what do you lose? An electron. Yes? So therefore the neutron would become a proton. Okay? So let's just, even if you've already done it, let's do this one. Well, we'll do sulfur 35. So S 35 undergoes beta decay. So then we would write it like this. What is one of the things that we would write here?
You would write beta or whatever. They
No, electron, 0,
Write a
negative
beta,
1.
which is an electron, -1, 0, E, right?
Wait, isn't it 0, negative 1?
Yeah, that's what they wrote.
0, -1. And then this is sulfur, so this is here, yes? What happens to its atomic number? Goes up 1, right? Even though the atomic mass doesn't change. So it's still 35, but we go from sulfur to chlorine, yes? And it becomes chlorine. Good, everybody's okay with that? Yes? Great.
Wait, why does it change?
Because a neutron gets turned into a proton.
So
So
bumps
this
up.
number, well, the element name, right, is representing the atomic number,
Okay.
right? So you go from 16 to 17 protons. Okay, doke. Good? Great. Yes. Good with that. All right, half-life.
Beta decay is neutron to proton.
Beta decay is when a neutron gets turned into a proton. Yep. We ready to do half-life? Okay. Half-life is the amount of time it takes
Oh my god. You might have that too. Wait, you guys were doing that?
the amount of time it takes for
That's
half.
push-ups.
No,
You said shut up last time for your push-ups.
It's just that, like.
That didn't
It's
feel
the
like something
same
God would
thing.
say.
I sing.
If I said shut up to Hayes, you would make me do
No,
push-ups.
it's not. No, really, it's
Jesus would not say that to
I
any of us.
promise you, it
Jesus
doesn't
wouldn't
have
even say the
anything
sh
to
sounds.
do with that. Shh. It is like shh. It doesn't. It's not a bad thing. So, can, this is what half-life is. Yes. Yes. This is what half-life is. So, did you all do this problem? Yes. Yep. Do you feel comfortable?
No, can we do it?
with Yeah, this is the part that the students have a harder time with. So this is the amount of time it takes for the material, for half of the material to undergo radioactive decay. In this case, it's 3.2 days. I don't know why it's 3.2 days, just a number. Maybe it actually be true, right? So this is 16 days you've had this sample for, right? When you start off, how much of it is indium-113? 100% of it, right? Does that make sense? Now, how many half-lives have you gone through? How do we figure out the number of half-lives we've gone through if a half-life is 3.2 days and we have 16 days? What is the math that helps us figure that out?
16 divided by 3.2.
Beautiful. 16 divided by 3.2. Does everybody see that? Yes? And did you do that on your calculator? 5. Get your calculator out. That's 5 half-lives. You still need your calculator out. Everybody has their calculator out, Anna? So this is 5 half-lives. What does that mean? That means we have basically to do this thing 5 times. So we're starting with 100%, right? And after 1 half-life, that's 100% divided by 2. So how much would we have?
50.
50%. That's 1 divided by 2. This is our second half-life, right? 25 divided by 2. This is our third half-life. That's 1, 2, 3, right? 12.5. Does everybody see this? Divided by 2. That's 4. Yes? And that is what, 6.25?
3.125. Or wait.
What?
6.25. So 1, 2, 3, 4, and then we have one more half-life to do. That would be our 5th half-life, yes? And then, that sounds like you have a 3.125, yes? That's how much we end up with. So do you see how we use that number 5? Yes? We had 5 half-lives, so we divide it by 2 5 times. This ends up being the exact same number because we started with 100 grams, but you could start off with 54 grams, you could start off with 27 grams. Doesn't have to be 100, right? Yes.
Will we ever have it where we don't, for like the percent of, for A, will it ever not be 100%?
100%. I have to say, I don't think so, but it didn't really matter.
Okay. Yeah, so you just
Generally,
keep doing the same thing.
you just do the same thing, but generally you start off with 100% of the thing and you see how long it takes.
Okay.
But you definitely would end up, you could end up with something that's not 32 days, right? Like it
Right.
could be any numbers.
Right, okay.
Yes? Zach, you okay with this? Yeah. Good? Yeah? Great. Okay. So, that's half-life. It's good you guys went through that. This is just, this should not be that hard, right? Yeah? Okay. Can everybody calculate molar mass?
Yeah.
Yes? Yes? You can calculate molar mass? So you're gonna have to be able to calculate molar mass, you're gonna have to be able to convert, right? Should we just do one just to make sure we can do it?
Yeah.
Let's not do that one, let's just do a different one, okay? Can I give you these? Here, we pass these out.
Can we round on the test to the whole number?
Yeah, round to the 100th decile.
Hundredths.
I mean for the molar mass. Like,
Yes.
could we just say 28 or do we have to do the decimals?
No, I mean, if you round to the hundredths, right, so like, let's say you're looking at oxygen, right, that'd still be 16. But if you're looking at hydrogen, right, then that's 1.01. Yeah? So just round to that.
Okay.
Okay, so let's just say we have, whatever this is, CnH2, okay? And we have 47 grams of it, how many moles do we have? Okay? So this is the task that we're gonna work on right now, is how many moles of this substance we have.
Are we a 47?
You need paper?
So that's,
Right? So we get our atomic mass, yes? That should be 2, 6, 8, so 18.04. Is that what we got?
No,
Oh,
28.04.
Oh, 28. 28.04?
Yeah.
Yeah, I do. 1 plus 1 is 2. 28.04, yes? So then this is 28.04. This is grams per mole. That's what that number represents, right? And then we say we have 47 grams, right? 28.04 grams makes 1 mole. Yes? And then we do that math. Back.
It's 1.68.
And we get, did everybody get that? 1.68?
Mr. London, I rounded, so I just used 28. Is that fine?
That's all right. I think it's, I'm not gonna.
Yeah, 'cause I get 1.67. So
Okay.
Six.
Everybody's okay with that, yes? Yes? Great, awesome, all right? We have lots to do, so, okay. Copper cycle, we feel comfortable with copper cycle?
I hate
Oh, what has the copper cycle ever done to you?
No, like
So annoying.
I struggle with like step 5, because when it gets to like
This was a fun unit.
equation, it gets a little bit.
Someone can help you with step 5.
Oh, because that's what I did in project.
Yeah.
It's like oxidation,
Uh-huh.
so it's like,
Beautiful job.
it's copper plus oxygen plus,
You did great.
water and
So this actually, it works well with the reactivity table. For some reason, I only have 3 of these here, but you may want to share these.
Can we turn the AC off, please?
Yeah, please.
That, please.
Sure. Do you need me to do that, or can you do it? Can you do it? Zach, you'll just have to look around. All right, so, do you see zinc here? And copper. Zinc wants to give its electrons to the SO4, do you see that right there? More than copper does, okay? And so what zinc is gonna do is it's going to switch places with the copper. And so zinc is more reactive, it has a higher reduction potential. It wants to give its electrons more, so that's what happens. This thing right here, SO4, do you guys remember what that is called?
Sodium oxide.
Okay, you wouldn't have to remember that. Just the general name for this, is there more than one atom?
Yeah.
So it's polyatomic ion, right? It's a polyatomic ion, yes? So this is a polyatomic ion, and it's an anion, it has a negative charge. Zinc would be the cation with a positive charge, right? So you have to have a sense of those components.
What's decant?
Oh, decant is just when you pour off the liquid because the solid falls down to the bottom, right?
Like a strainer?
No, it would be like if you, I don't know, you had like a bunch of rocks and stuff, instead of just pouring it out like that so the rocks fell out, you did it really slowly.
Oh, in a solid state.
Yeah.
Can we go over 14 or 13 and
Repeat,
14?
can you say it louder?
Can we go over 13 and 14?
Yeah, we can go over 13 and 14. Is everybody okay with this?
Yeah. Wait, so is it SO4Z then, or Z?
Yes, so what this ends up being is ZnSO4, and then the copper is the thing that gets kicked out.
Wait,
Because the zinc wants to give the electrons
Mm-hmm.
to this
Just
SO4 more?
pretend you go to the dance. Sorry, with the copper,
Okay.
yes?
Ooh.
And then you're at the dance with the copper, but then zinc shows up, and zinc is
Wait.
like a lot cooler.
Wait, does
Zinc's better,
SO4 want to give its
You are
electrons?
SO4.
Oh, so
Yeah.
it, SO4 wants to give its electrons to zinc, not the other?
No, it wants to gain the electrons of zinc.
Zinc wants to go with you.
Okay, that makes sense.
Yeah, and then zinc
Okay.
pushes copper out of the way and
It would
ends
not
up.
be that helpful.
Yeah, I think. Okay, that makes sense.
Was that one of my non-helpful analogies?
No,
It
no,
was
no,
not-
it's
it was-
just
it
funny
was
that
like-
that's
yeah.
how it's helpful.
All right, are we okay with that? Now let's do these two. Questions? Write a balanced chemical equation for the following. So you will have this, when you're asked to do this, you will have this here, okay? So, do you see that this says nitric acid? Colorless nitric acid, right? So that's HNO3, yes? Is added to a solid orange-brown copper,
See you, right?
plus Cu, yes? And then that's going to form, resulting in a blue-green solution. So what is the blue-green solution gonna be? CuNO3 parentheses 2 plus over here, resulting in a brown nitrogen dioxide gas, NO2G, right? And this would be AQ, yes?
Where'd that 2 come from?
Water.
Where'd that 2 come
H2O,
from?
I'll tell you in 1 second. Okay, so everybody sees all of this, yes? Okay, first of all, you're told this using this, but oh no, we talked a little bit about this, but I don't know if you remember. So, because this is 2, if you look at your polyatomic ion sheet, and you should have that on this. Do you have the two review sheets? Yeah? The new review sheets. This is polyatomic ion sheet. You're gonna have to get out your, you can get out that work, but you remember that sheet that has all of the polyatomic ions?
Yeah.
You will be given that sheet. Okay. Yep, the anions and the cations. And so, you will look and you'll see NO3 is an anion with a charge of -1. So if NO3 has a charge of -1, what do you know the charge of copper has to be?
Positive.
Perfect. +2. Turn to the person next to you and say why you know the charge has to be +2. You two.
Because of
sorry.
two. I know 3s.
We know this is a charge of -1. How do we know that copper has to be a charge of +2?
Because there's 2 of those NO3s.
Well, it's because,
And it might help if I did my
there's 2.
drawing,
Yes.
right? You see that that's a 2?
Yes.
So there's 2 negative NO3s,
Yes.
right? So -1, -1, that means copper has to be a +2. Does that help, Anna?
Yeah.
Good. All right, are we good with that?
Yeah.
Do you want to do another one, or should we move on?
Well, we need to balance it, right?
Oh, yeah, we need to balance it.
Balancing took a second.
Did it take a second?
Yeah.
All right.
I didn't get the balancing part.
Should I rewrite it? It's really ugly right now.
Yeah.
Oxygen, okay.
It's 3, C.
You shouldn't call it ugly, though. It's not very nice.
Six. That's 12. Now what?
What?
Okay, HNO3 plus Cu.
That's still 12.
You might want to
Yields
send the video to Fishtail.
Cu.
Because Fish is
Oh yeah, where's I?
And
Oh wait,
so,
yeah, why'd we just skip it
3.
to Kieran, right? All the
2,
absence.
that's 3. Yeah?
Plus
Plus
being
First like
compassionate.
5 minutes.
NO2
Yeah.
plus H2O. Good. Everybody's happy?
Yeah.
And this is aqueous. This is solid.
Do we have to like write that? The
Yeah.
aqueous solid and all that on the test?
Gas. Gas. Liquid. Yes.
Wait, how do we know that it's aqueous or solid or gas?
Because it
It says on the
says,
chart.
yeah, it says in the chart and solution. You see that word?
That means aqueous.
That means aqueous, anytime there's a solution. So then we look over here and we're like, all right, how could we do this? So right now, copper's balanced, but that might not be the same thing. Oh, definitely we're gonna have to put a 2 in front of this to get that, right? So we'll put a 2 here. Everybody's okay with that? Yes? Yep.
Is water the only thing that could have an L, like for liquid, or is like
Yes, water's the only
What
thing that's
about,
gonna be an L. Nope.
Everything else is just AQ.
It's gonna be AQ. I mean, like you can do liquid mercury, but
yeah, that's
you're
what I was
not
thinking
gonna
about,
have
or like liquid oxygen.
Yeah, I mean, you can, but you're not gonna have that. Okay, So then that, we have 2 there. Now let's count up our, right, so is that gonna cut it? No, because that's 2, that's 3, right?
You would have to add the 3.
Right, so then if we have 3 here, will that work?
No.
No.
No, that's not gonna work. So we put a
A 2.
have to put a 2 here.
But then
Yes?
nobody's wearing a jacket. It's kind of
Does everybody agree with that? Yeah, I haven't balanced this, but so you guys can help me. So that's 2, so this would make us, does that make us 4 here?
Yeah.
Yes? 4. Good. And are we balanced or not?
No.
No, you
H.
you put
2 here, yes?
We got 2.
And then you're done.
And then that's it? Yeah?
Wait, wouldn't that be a bigger two?
That, yeah, which one would be a bigger 2 one, I'm sorry. I just didn't wanna mess it up with a plus. That's not a superscript, it's just, it's not that space. We okay? Good? So that's how we balance? Yes? Alright.
We do 14 too.
Yes?
Do we?
Are we gonna get the copper
Eight.
Yes, you will get the copper cycle chart. Alright,
Wait, did you?
this is the one that we did. Zn solid is added to copper sulfide at Cu
SO4.
SO42, right?
And then so 4.
AQ.
Wait, so we have to like memorize what the chemical formula is?
No, no, you're gonna
It's on
have.
the-
It's
on the
website.
So since copper is always willing to give 2, you have to make the other one 2.
Zn
So that should be
SO4
Copper always wants to give 2, so this has to be.
2 plus Cu. Is that right? Do I have the whole thing? written
Yeah.
down?
Yeah.
I'm
So
just
I would
doing
have
it
to
from memory here.
Wait,
No.
This is
How do you know if it's Z?
So that's right.
wait, why did you
I've
put the
never
2?
Yeah, why do you know, how do you know if it's 2?
Just know
How
that
do I
since
know to
it's
do
copper
that?
wants to
You mean
zinc?
Oh, cause
It's
zinc is plus,
I don't like that.
Yeah.
oh,
Oh, wait.
that's like the one thing we need to memorize for that.
No,
This is it.
you don't.
Because it's not on the thing, so
Okay.
yeah.
So this is the thing, these are transition metals.
Yeah.
They can take multiple numbers of electrons, right? You would not be required to memorize or learn that. Well, with the exception of the fact that you have done this in the copper cycle, and we've gone over this multiple times. So in that case, you do need to know that zinc can take 2, but short of that, you don't need to know that. Yes?
Would you ever give us like an equation and not tell us the product, and we would have to figure out like which ones fit with which, because
Sure.
like which ones can take electrons?
What? Wait, can you re-say that? What'd you say?
Like, he would give us an equation, but not like products. No, I mean like a bigger equation where like there's like multiple different atoms, and we have to figure out which ones go with which, because like
No.
which ones
I
can
would-
take the amount of electrons
But
that
it would
would
all
make
have
it
to do with
fit.
the copper cycle, right?
It would-
So
it would
I
have
could just
to-
look at the thing and then
Sure,
go,
although, to be fair, right, might I do something like this, and then just put a blank there?
but like in the thing, it would say like a silver gray.
Yeah, but even
So
if I
that's,
did
like,
this,
not bad.
if I gave you this equation, you could figure out that zinc is the only
Yeah.
thing that's left
Because
there,
you
right?
would get the product.
Yeah, so that would be just looking at the products and reactants, you can,
I
you'll
was
totally
basically
be
saying,
able
are
to
you
do that.
stupid?
She's literally saying.
How do you not know that?
Yes? Alright, are we okay with this? Good? Yes? Grand. Done with that one. Alright, now we're going to move to Unit 6, which is small.
Is it on Schoology anywhere?
Remember the water
I
cycle
can't
song?
find it.
The water cycle. It is absolutely Mr. Fong. You gotta
Do you have to go into materials? Do you guys see materials?
Cycle.
Do you see finals preparation? Yeah?
See unit 5, unit 8.
Yeah.
Did you give us unit
It's in
Yeah,
there.
there's 2.
Are we
Kendall,
supposed to?
you know where the like agendas
Oh,
are
it's
for like the
this.
review days?
Yeah.
It's in there.
Okay, but
This is unit 6.
I'm so short.
Wait, but there's only
Or
Yeah,
there's-
6, 7.
We didn't have a unit
It's
6
not-
test or
it's
was it
not
a
posted.
quiz?
It's not.
Wait, there is a
Oh, is
Okay.
that the short unit?
do you see this right here?
It's the 6
Review
is
for final,
Yeah, but it's
review
not
docs
posted.
and links, Unit 5, Unit 6,
We can
Unit
only
7.
see
We
unit.
can only
We can only
show-
see 5 and 8.
5 and 8.
Oh, I apologize. They're grayed out.
We can't see 6 and 7, like 6, 7.
I can't see that yours are great, like 6, 7. I can't see.
So
yours.
funny.
Oh my god, I'm so laughing right now.
Okay, give me 1 second and I will
Tough
make
crowd.
this.
Wait, JP thought it was funny. Zach thought it was funny. Mr. Labonte thought it was funny.
Mm.
Opening a new pack, of course.
Gary, you're not gonna.
Love you so much. That's so nice. Oh my God, I really opened it.
Scarlet.
Just right.
Scarlet.
I'm ready.
Okay, let's see, you should be able to see them all now. Can you update?
JP wants them too.
Can you
Yeah.
refresh?
It's there.
And now you can see them all?
Yeah.
Okay, alright. Good.
How to print that in. I wasn't here Friday.
I have 2 empty packs
Wait.
in my bag.
Can we see? Can we see 6,
And
7
wrappers
yet?
everywhere.
Yeah.
It's across the
You should
hall.
see my car.
Oh.
So gross.
Alright, so unit 6 review, yes?
Wait, can we see 6, 7 yet?
Alright,
Zach.
here we go. So, ahem. I want you to write this down first, okay?
Oil.
Oil rig. Regarding electrons,
Oil rig.
oil rig.
Sure.
Yeah, there's just one page though.
Yeah, that's all right. This is 6 is about. Oil rig stands for the following.
Oh, I don't know who wrote this.
Oxidation, it is, how many O's in lose?
LOOSE.
Loose is, wait, that's loose, it's,
Loose?
it's one.
Oh, oxidation is losing.
Oxidation is losing,
Please call me dumb 3 times.
please, can you do push-ups later? Oxidation is
Please.
losing,
Please.
Please.
reduction is
Gaining.
gaining electrons.
Wait, that
Okay?
doesn't seem right.
It is 100% right. So you have to remember that this is negative, right? If this is an electron, it's negative. So if I give it to you, you've been reduced. You've gotten something that's negative.
To me.
Does that make sense? So I'm positive now. Now I'm more negative because I got a negative thing. Yes? So that's reduction. You're getting something negative. Because we're only talking about the movement of electrons. All right, are we okay with that? Yes? Now, do you see this green piece of paper? You'll have to share right there, the green piece of paper. Look at the left-hand side of the green piece of paper. All of y'all are gonna have to share too.
Yeah, stay over there, sir.
We did this a few times in class,
Whoa, whoa,
right?
whoa! I did not.
So,
What are we looking at?
what element is all the way on the bottom of the left-hand piece of paper?
Lithium.
Lithium. What do we know about lithium? Tell the person next to you.
What do we know?
It
wants
needs to lose an electron in order to
and
become
get
perfect.
It really, really, really wants to lose an electron, right? So it wants to lose the electron, yes? What is on the top?
What are we doing?
Flora.
Hey, when I gave it-
helium.
Fluorine.
Fluorine.
Fluorine should be on the top, yes? A version of fluorine. What does fluorine really, really want to do?
Gain an
Gain an
electron.
electron. So do you see how this chart is organized? The bottom is a bunch of elements that want to lose the electron. The top are the elements that want to gain the electron. Anna, do you see that?
Yeah.
We're only looking at the lower right-hand side
Okay.
of the chart. Just the right-hand side, the right-hand column. Ignore everything else. And when I give you the test, yeah, don't fold it though, please. But when I give you the test, I am only gonna give you that left-hand column,
Gotcha.
just to try to keep your life simpler.
Just
Okay.
like left.
Wait, sorry, what?
When I give you the
He
test,
said left and right like 3 different times.
Oh.
Yeah. No, other side.
no, this side. This is what you're gonna get.
the right.
That's the right hand side.
You said
Oh, I said, I'm sorry. Yeah, I'm only giving
So we
you
don't
the
need the
right hand, I'm only giving you the right hand side. The left hand side is the inverse of it, but just to make
We
it
don't
look
use that?
easier. Yeah. We're just going with this. Okay, does that make sense? So, because you're only getting this right-hand side of this chart and you're only looking at this, do you see that the elements that are at the bottom are really, really, really gonna wanna give electrons?
Yeah.
To what?
The atoms on the top.
To the ones above them, right? The further apart they are, the
More
more they're
two-sided.
gonna want to give those electrons. The closer they are, the less they're gonna wanna give an electron. No element on top would ever give an electron to an element on bottom, right? So, which are the elements that are going to end up being reduced? Point on the chart. Where are the ones that are gonna be, they're going to be reduced?
Lithium.
No, the top.
the top.
They're going to be reduced.
Oh, they're gaining a
They're
negative thing.
gaining a negative,
So
they're
the
be reduced, so that's gonna
Wait,
be the
isn't that the
top.
bottom? Because the bottom
right?
wants to gain
The
electrons.
bottom are going to be the ones doing the
Oh, they're giving
reducing.
away.
Wait, the top,
I remember hating this.
I know,
idea.
I'm
the
sorry.
top
say it
wants
again.
to reduce?
Okay, I think it's most easy if you just look at lithium, right?
Mhm.
What does lithium wanna do?
Give an electron away.
Give an electron, yes? Does that make sense? It's going to give its electron to anything above it,
Which
yes?
is gaining.
And so when you gain an electron, you are reduced, right? Yes?
Yeah.
Reduction is gaining. So the ones on the top of that chart are going to be reduced, yes? And the ones on the bottom of the chart are going to be oxidized,
Oxidate, okay.
yes.
Wait, I remember on the test, like, you
Yeah,
told us
yeah,
like
yeah.
copper, but there's two coppers, so like,
I had to tell you which copper, do you remember that? If
Yeah.
it's, I'll highlight which one it is,
okay.
if it's that. That's just, remember we talked about copper, zinc, all of those are transition metals, so they behave differently at different times. Yeah,
Wait, so like, does cobalt or like nickel or one in the middle, do they want to like gain like that many electrons, like 10 or
no,
whatever?
these are, we're intentionally not going into the details.
Okay.
Okay, does everybody understand how this chart works?
Yes.
Yes? It is important that you understand how this chart works.
The H2O's the middle then?
Yeah, the water is the middle, isn't that cool?
Yeah.
Yeah.
That's like the right.
So this is the.
Is water perfect or perfectly
No, it's just what we
imperfect?
end up using. Okay, everybody's okay with that? Yes? Zach? Yes? Yep. Alright, so, oxidation's losing, reduction's gaining, alright? So let's look at this, let's look at number 5. Zinc. See, actually, you guys work to write this out. What happened to zinc and what happened to copper? Use the terms oxidized and reduced. Don't say it out loud. Yeah, give me 1 second and I don't know, I usually make like 5 extra.
Wait, I need a 5 and a 6. Thank you.
Talk about number 5, the chemical equation, and like
Well,
using
oh,
oxidizing and
You're so
reducing.
exact.
Oh, I hate this unit.
JP, how was the meeting with the coach?
It was cool. You just
Bro, I bet all the JV guys are gonna say like, I hate Sam.
Nobody asked.
Yeah, I
me
probably
anything
will.
about this.
Do you want me to explain it?
Coach.
So you see how zinc, look,
I got a bunch of good feedback.
you see how
Jeremy.
zinc gained, or turned to 2 plus? And you know an electron's negative, which means it lost 2.
G,
I'm sorry?
oxidized, AB.
Since it lost 2,
Alright, you ready?
Yeah,
it's
you're not him.
losing 2, which means it's oxidizing.
It's just shush, by the way, that's not me giving them out.
Probably is. Shit. Whoa.
Whoa.
Push up.
JP has to do his for calling me dumb 3 times.
Self-control.
Keep it on the
Alright.
tab.
Let's look at
you
this.
with you?
Go out there. I don't wanna talk about this.
Put it on the
Look.
tab.
We're just gonna look at zinc. What happened to the charge of zinc? It became positive. So what had to occur?
It lost 2 electrons.
It had to have lost 2 electrons. So zinc became
Oxidized.
oxidized. And copper
Reduced.
reduced. Yes? Because copper
And it just
gained,
brought copper to nothing.
yeah, it gained 2 electrons, which brought it to nothing. Okey doke. How about this next one? Is
That was
tin
not
easier
tin.
to oxidize
Put on God.
Could do 10 if you
than
want.
magnesium?
Put on Jesus Christ.
How do you know?
Tin is less reactive.
Right, is you used your table?
Yeah.
Yes? Does everybody agree with Anna? I actually don't have.
Wait, zinc oxidized, right?
Tint.
And
Tin,
then-
SN.
Oh, SN.
Where's the
Tin is
second?
SN.
Wait, what's the question?
And is magnesium
Which one oxidized and which one
Yeah.
reduced?
Hmm?
Yes. Wait, how do I know?
You actually,
Okay,
it's wrong because you
So
didn't use reduced to
oxidized
oxidize.
is losing an electron, right?
That's right
So
there.
what we're looking for is which one of these is lower?
Oh, magnesium.
Magnesium, right? So magnesium is going to be easier to oxidize than tin,
Because it's lower on the chart.
because it's lower on the chart. That means if you put magnesium and tin together, magnesium would give electrons to tin, right?
Is that allowed?
Is it allowed?
Well, I thought you
Yeah.
could only give it something that's above the H2O.
No, above it.
Oh,
So
okay.
magnesium
Yeah,
wants
this
to.
isn't, wait, let me
Sorry.
restate that, because I wanna make sure that that's not a misconception that other people have. You can give electrons to anything that's above you, if you're that element, right? Lithium can give electrons to anything above it. Yes?
Yeah.
H2O happens to be 0, but it doesn't really matter.
Got it. Okay.
Yes,
Wait, so magnesium wants to oxidize or give away electrons more than tin, so it will, like,
when you say want, you wanna say reduce. Give
Yeah.
away electrons is reducing, right?
I thought it wanted to oxidize more.
Okay, to be oxidized.
Which isn't oxidize losing electrons?
Yes, to be oxidized. Look,
So it wants to, like to
I
be-
have the electron, right? If I give you the electron, I have reduced you, and I have become oxidized.
So it wants to be reduced more.
Yes,
And that's
sure, you can
gaining
say that.
electrons?
Yeah.
Magnesium is so.
That's
I wish, the language is confusing, I don't, but that is what, the language is what the language is. All right, can we go to batteries? Okay, so. Does everybody see this image?
No.
Yes? Okay, so. Here, can you read that word, that's anode?
Yeah.
And this is cathode?
That's-
So, do you see that there's an arrow here this way? So the cathode is giving the electrons to the anode. In your green sheet right in front of you, can you come up with potential cathodes and anodes, given what we just said about who wants to give the electrons?
Would it be lithium as a would it be lithium as a cathode and
Yep.
fluorine as the
So it could be anything that's lower down would be the cathode, and anything that's above it would be the anode.
is that why lithium batteries are like the best?
That's why lithium batteries are the best, because lithium wants to give the electron the most, right?
Oh, so
The
they-
most, right,
the most-
what would be the most powerful battery you could create?
Lithium.
Hydrogen.
Lithium what?
Lithium
Fluoride.
Fluorine.
Boom, lithium fluoride, right? So if this is
Do
Li,
those exist?
yeah.
Are those like our AA batteries?
No, these, even lithium batteries blow up a lot, like light on fire. You know
Is
how
it- Is that like a plane?
you have to be careful about the batteries on the plane. That's because lithium really, really wants to give those. So lithium fluoride, that would be the most powerful battery you could have, right? But hopefully you will recall, what happens when you press, maybe lithium fluoride, no, still. What happens when you press lithium and fluoride together? Did you get voltage?
Yeah, no.
No. You need to have something in between to
Soy water.
carry it, and it has to have an ion.
Oh, like the carrier thingamajig where we
Has
like
to be
carry
an
the
ion
markers.
solution,
Oh, this is confusing. Okay.
which is an ELCTRO.
Wait, is the blue stuff the ionic solution?
Yeah, yeah, It has to be, you have to have an electrolyte or some kind of a solution that has an ion in it that's gonna carry the charge.
So what's like our AA battery then?
So like what?
A car battery is lead and copper.
So,
Yeah. Sorry? Yeah, I mean, it's pretty good, right? And it also depends on how big those anodes and cathodes are, right? But actually.
Why can't we use hydrogen in a battery?
Okay, so let's look at this. What is in a car battery? HCl, hydrochloric acid. What happens when you put HCl in water?
Goes to-
It turns into H2.
Right? It's gonna turn into H plus Cl minus. You should definitely have a sense of that, yeah? So now you have little H pluses hanging out over here, yes? They're gonna pick up the electron, truck over, and drop it off.
Oh,
That's how, the electrolyte allows those electrons
So that's
to
the
move
ionic
through.
solution.
Yes, so this is the ionic solution right here. Or you could also call this an electrolyte, right?
Bless you.
AQ. Now
Bless you.
what did you use as an electrolytic solution?
A
in
lemon.
The battery that you made.
The acid no
The acid in
lemon.
a lemon, right? So it's the exact same thing because you had hydrogen ions floating around.
Wait, what is the acid in the lemon?
Like you were out of
It's citric acid,
Obviously.
right? Yeah, so we're focused on this. That's the acid, and it doesn't really matter. Any acid will do that. Any ion will do that.
so it moves the H pluses.
It allows the charged particles to pick up the electrons.
Is hydrogen the only thing that can pick up charges and move them from one to
Nope.
the other?
So if you put salt water, right,
So,
and you could run salt water could be the solution that runs it
And
out.
can it do it unlimited
Yeah,
back and
because
forth,
if
or
you
do you
put
need to like
electrons,
replenish the solution?
it has to.
No,
Or the
it goes
acid.
back and
Oh,
forth,
because it
because
need to be opposite.
on this side, what happens is that hydrogen will drop the electron off, right? And then it becomes charged again. And then it gets attracted back over, it becomes positively charged, so
So
it
it's
gets
like ping
attracted to
pong.
the negative
just back
side,
and forth.
right? And then it bounces back and forth. So those atoms go back and forth and back and forth. Yes? Yes.
What happens to the chlorine when this is all happening? Is it just?
It's, in that case, you could
If they
just,
break
for your
apart.
purposes, it doesn't do it.
Okay.
Yeah, it just floats around in the water.
Okay.
40.
Okay, okay, so I think does this make sense how a battery works?
Kinda.
Okay, let's look sorry, 1 second. Yes, Jeremy, what?
No.
Okay. Shall we look at electrolysis?
Sure. That's not the bubbles go to the top, right?
So electrolysis is kind of the opposite of a battery, right? In electrolysis, what you're doing is you're pushing electrons through. Right? So this is just water, right? Let's not do that.
Is there a charge battery?
yes. And that's the way that you could charge a battery. This is doing the opposite, right? So this is OHH, and then hopefully you will remember, you're gonna have 1, 2, 3, 4, 5, 6, 7, 8. Everybody understands why I put those electrons there, yes?
Yeah.
Yeah? Okay. Now, all of a sudden, I'm like, hey, I'm gonna jam another electron into this. Well, when I do that, what happens is oxygen will break off with a hydrogen, and that electron will go onto it, and that will become OH minus.
Wait, so oxygen breaks off with the hydrogen or with an electron?
And an H plus. So what happens here is you get H2 gas. That's not, I'm so used to writing H2O. H2 gas.
Wait, why H2?
Because, so what happened, do you see right here, you
Right.
see how the electron had that hydrogen there? That happens a bunch, and you know that hydrogens are happy with sharing electrons, so that's why it's H2. You mean instead of just H?
Yeah, just H.
Yeah, H2, because they bond
The
together.
bonding thing. Okay.
So this happens twice to give you H2,
Mm.
yes? Let me finish the story. So does everybody see this thing right here?
Yeah.
This is actually, so this will carry the electron in the water solution. This will go, the OH will go over here, and then it will drop the electron off here. So now, this electron leaves. If you have another one, right, because you have a ton of these things, and both of them lose their electrons, now they're unhappy, yes? So guess what they're gonna do? They're gonna bond back and make H2O. Well, if this is H2O, what is left?
And oh.
An O. Yes?
This is so confusing.
Plus an oxygen.
What's happening right now?
Can I ask a question?
I'm walking you through this. You probably won't have to know this.
Then why are you
So,
teaching?
so,
I feel like it is part of it.
wait, so you're telling me
It's
all
so
of this-
confusing.
Because I'm really
But I
lost.
will back off on this. You don't, you don't have to know this.
Oh,
Okay.
thank God.
Wait, so what do we
I've been
not
checking.
know?
I was just sitting here staring at
I
the
was just,
screen.
yeah, I don't even know what's going on.
I do want you to know this, okay? So if you don't,
Well, the
you can't-
anode cathode, yeah.
you
okay.
can't peel that apart. On the side of the cathode, you're gonna have H2. On the side of the anode, you're gonna have O2. That's all you have to know. I was trying to explain exactly why you would have H2 and O2 on those two sides, but if that's too much.
And they're both gas.
And then,
Just say. Just
this is,
no.
if you,
Just no.
you can just memorize that.
Okay.
And then in the middle we have what?
The
This-
water.
No, oh wait, no, it's
That's what I
it's plus something.
Oh, an ion, you don't have, don't worry about
Okay, bye.
Wait, there's one up there?
that. No,
Bye.
you don't have to worry about that. Okay? So, on the cathode side, you're gonna have hydrogen. On the anode side, you're gonna have oxygen. That's splitting water. That process is called electrolysis.
That's splitting water.
Uh-huh. Lysis is to split, right? So you're using electricity to split water.
And so you have like a cathode on one side and an anode on the other side, and then like the acid or whatever takes an electron from the cathode, brings it to the anode, then when it loses it, it wants another electron, so it goes back to the cathode, picks it up, then brings it to, like, it just goes back and forth.
Yep, that's exactly. And do you guys understand the little picture of the redox reaction on the bottom?
Sure.
This?
Oh, because plus and minus
yeah.
equals 0, and 0 and 0 equals 0.
It's just oxidation and reduction.
Yeah, that's just oxidation reduction. All right, should we go on to the next unit?
Perhaps.
We have to turn this in.
Yeah, I do wanna see those.
Wait, I want to use
Should
it
I
though.
be turning in 5 and 6?
Wait, can we post a picture of it instead?
Yeah, yeah.
Can I do it?
Do we have to fill
Yeah,
out
is
the
it-
rest of
is
this?
it-
Does I need
Like these
Um,
questions?
yeah, fill out the questions. I don't really care if you fill out the vocab. All right, are we ready for 7?
6, 7. Wait, which one from 6?
How much time do we have?
5 minutes.
5 minutes.
Mr. Labonte, which one's
Or
from
should
6
we
I'm
to
gonna
wait
stop.
until
7?
let's just stop
I'm
early.
gonna stop and let you all review.
Oh, nice.
Guys, we just went from unit 6 to 7.
it. Exactly.
Say more.
Wow.
Say more.